In this video, we're going to take a look at what current electricity is. And so by the end of this video, you're going to be able to explain how electricity flows in a circuit. You're going to be able to identify the parts of a circuit, and you're going to be able to explain how energy sources provide energy to a circuit. So we first need to start off with, well, what is a circuit? To operate a device like a light bulb, you need a constant stream of electrons. So, unlike static electricity, a flow of electrons requires a couple of things in order for the electrons to continuously flow. It needs a complete path to follow and a direct energy source. And so this complete path is what we call a circuit. So if you take a look at our example here, you can see all of our electrons flowing. These are the little blue negative charges here. We have an energy source. The electrons flow through that. They flow through a switch, and then they flow through the light bulb and then back to the battery. So it's a complete path. Now, if we're to break the path, like open the switch here, and the path is broken, the electrons will no longer flow and the light bulb goes off. Okay, so a circuit always requires that complete path. Now, what are the basic parts of a circuit? Well, a circuit has to have three main components. The first component is a load. And so usually what we use is a light bulb. A light bulb is a great example of a load. And a load is just a device that's going to take electrical energy and convert it to some other form of energy. So, for example, a light bulb is going to take the electrical energy and convert it into light, okay, and give off light. You could have, for example, phones are going to take that electrical energy and convert it into light through the display screen. So there are lots of different loads that you can put within a circuit. The second piece you need is a conductor. And so these are wires that are usually made of copper, and then they have that rubber coating to insulate them and direct the flow of electrons through our circuit. And finally, the last thing you need is an energy source, which is typically a battery. It could be an outlet that we have our devices plugged into as well. And all batteries have a negative and positive end, and we're going to see the purpose of that in a little bit later in this video. Now, another optional piece that you can have in a circuit is a switch. And most circuits do contain switches because this allows us to be able to turn a device on or off by opening or closing the switch. So when the switch is closed, as in this picture here, or we have it turned to the on button, then we have a complete path. And so our light bulb lights up. If our switch is open, then that means we would have this in the off position. And since we no longer have a complete path, our light bulb doesn't turn on because the circuit is incomplete or broken. Now, the other part of our circuit that we do want to take a little bit of a closer look at is the battery itself. Batteries are really interesting and actually pretty complicated in terms of their chemistry. So, we're not going to go into too much detail here. But the main components of a battery is that it has two electrodes. We call the positive and the cathode, and we call the negative end the anode. Doesn't really matter about the terminology, but those are the terms if you're interested. And those two electrodes are connected to each other in a solution of what we call an electrolyte. So, an electrolyte contains active ions that are willing to react. Electrodes are typically metals on each of the end of the battery, and then they react with the electrolyte that's inside the battery. Usually, these two electrodes here are also different metals. Nickel and cadmium are two examples, but there are lots of different types. Now, when we take a battery and we connect it to a circuit, electrons are going to flow from one end of the battery all the way around our circuit back to the other end of our battery. Now, which way do they flow? Well, we remember we had a cathode, which I didn't say in the last slide, but that is the positive end of our battery. And then we have an anode, which is the negative end of our battery. Now, because electrons are negatively charged, they're going to want to move away from the negative end of the battery because they're getting repelled by that end. And they're going to move through our circuit to the positive end of our battery because they are attracted to the positive charge. So electrons move from the negative terminal around our circuit back to the positive terminal. And that is the direction of electron flow within our circuit. That's it then for this video. That was a bit of an introduction to current electricity. We're going to get more into some of the details in following videos. So let's move on to our next task.